Guys, up and going. So, second. Probability. All right, so you can get down in. That's what we're looking at today. Probability. So, probability is small enough as regards the amount of content, but it makes up 2 questions on paper 2. So, first thing we have in probability is the principle of fundamental counting. So, with the principle of fundamental counting, the technical explanation is if one task can be accomplished in m ways, and the following is the second task which will be accomplished in n ways. The first task followed by the second task can be accomplished in m times n ways. You don't have to know that at all. You don't even have to know what it means, as there's a very basic explanation. All right. So what that means is a lunch special includes 1 main item, 1 side, and 1 drink. How many different meals can you choose if you pick 1 main item, 1 side, and 1 drink? So what this is if you were to do this long way, you have to go hamburger, chips, juice, and then you say hamburger, chips, water, and then you say hamburger, chips, milk. You have to go through every single one of the options. But there's a quicker way of doing it. We can say that it's 4 by 3 by 3. It's 36 different options. The reason it's 36 different options is 4 main items by 3 sides by 3 drinks. So, for example, a sandwich can be made with 3 different types of bread, 5 different types of meats, and 2 different types of cheese. How many different types of sandwiches can be made if each sandwich must have a bread, a meat, and a cheese? Anyone any idea? Why 30? 3 by 5 by 2, which is 3 by 5 by 2, 30 different sandwiches, alright? So that's the fundamental principle of counting. That's the first little bit. Right, the next important thing. Top of your copy, under probability, write down and means multiply, or means addition. Very, very important in probability. And means multiply, and or means addition. And we're going to come back to that in a minute. So, things we must know in probability. Probability ranges from 0 to 1. Is that right? You can't have probability less than 0, and you can't have a probability of something greater than 1. So, what would a probability of 0 be? For example, an impossible probability or probability of 0 would be rolling a 7 on a regular dice. Why would that be an impossible probability? There's no 7 on dice. It goes from 1 to 6, exactly. An example of a certain probability, a probability of 1, will be the sun rising tomorrow. Even though we can't see it, the sun rises every day. So the sun rises, even though we can't see it on most days, the sun rises every day. That will be a probability of 1. Something that is certain to happen every single day. So that's all up here. And then rolling a 7 on the dice is all up here. What would be in the middle? Give me anyone know what would be 50-50? Exactly. Flipping a head and a coin. Because when you flip a coin, you have 2 choices. You heads or you tails and stuff. Next. So, how do we figure out the probability of something? We put the total number of possible outcomes. We put the total number of outcomes over the total number of possible. So what I mean by that is, for example, if I asked you what's the probability of selecting a blue here, it would be 2 over 8. Why? Because there's 2 possible outcomes over possible. 1, 2, 3, 4, 5, 6, 7, 8. So, probability of blue would be 2 over 8. You must always break it down with the solution mark. 1 over 4. Probability of green. 3 over 8. Probability of yellow. 2 over 8 or 4. And probability of red. Exactly. Probability of something occurring. It's important you know a bit about cards. Cards won't be as well. So, if a card is drawn from a pack of 52 cards, does anyone know what's the probability of picking a black card? 26 over 52 or it's half the deck of cards is black. Is that okay? What would be the probability of picking a king? 4 over 52. Why 4 over 52? 4 kings and a half. Alright, so knowing a bit about cards is important for probability. Is that okay? The next thing, if I actually cards, king is 1 over 13. What would be the probability of picking a face card? I.e., a face card is a card with a face on it, like a king, queen, or a jack. Well, 12 over 52, how many face cards? There's 3. Times 4 suits, which is 4, 12 over 52. Is that perfect? Alright, so they're important little things to know. So, as I said, numbers on the dice go from 1 to 6. Very important. When a fair dice is rolled, they will often say a fair dice, or some people, or sometimes it comes up in the book as a fair die. Alright, very important. A die is the same as a dice. We just call it a dice here. Some people call it a die. Okay? In a 52 card pack, there are 4 suits. Diamonds and hearts are red. Spades and clubs are black. Each suit contains 2 to 10 number cards. A jack, a queen, a king, and an ace. An ace isn't considered a number card often. It'll tell you in the question. Is that okay? The next thing. Probability of something not happening. So, probability of something not happening is 1 minus probability of something happening. Why do you think it's 1 minus? What's the telling probability range? 0 to 1, exactly. Probability range is 0 to 1. So, for example, you win a game of bullseye if you hit the middle of dartboard. The odds of you hitting the bullseye in the game is 3 over 20. You have 3 in 20 chance of hitting the bullseye. What is the probability of you not hitting the bullseye in a game? 17 over 20, because it's 1 minus the probability of hitting it, which is 3 over 20, which is 17 over 20. Probability of not hitting something, take that yellow box out of it, alright? Probability of something not occurring is 1 minus the probability of something occurring or happening, whichever word we want to use. Right. Next. And and multiply. So I told you there's a big difference between and or. And means, or means plus. So if we look at the following. Sean has a bag of 10 marbles. There's 2 red in it, there's 4 blue, there's 3 green, and there's 1 blue. So this is Sean's bag of marbles. And the question asks us, Sean picks out a marble, then puts it back and picks out another marble. What is the probability of Sean picking out the blue and the red marble? So what happens here is, what's the probability of picking out the blue? 4 over. Probability of picking out the blue is 4 over 10. 4 over 10. He puts it back, so there's 50, 10 marbles, and then when he picks out a red, what's the probability of picking out the red? 2 over 10. So that's 4 over 10 and is multiplied by 2 over 10, which is 8 over 100. It's not plus, because it's and. The reason that's so high is, Sean has put his hand into the bag, pull out the blue, exactly a blue, and then pull out the red. So that's why the probability is so high. And obviously, as a probability, you must break it down 4 over 25, or 2 over 25. But that's the important word there. The important word is and means multiply just the probability. There are two important words of probability and or. A similar type of question with a different answer. Sean picks out one marble. What is the probability of Sean picking out a blue or a red marble? What's the probability of Sean picking out a blue? What's the probability of Sean picking out a red? So a 4 or a blue marble is 4 over 10 plus 2 over 10 is 6 over 10, or 3/5. Which makes sense if you think about it. There's 10 marbles in this, isn't there? You were allowed to pick out either a blue or a red. 1, 2, 3, 4, 5, 6. 6 out of 10 marbles. Once again, the important choice of word there was, whereas this one up here was. Is that okay? So that's the difference between the two questions. They're very similar, but the important thing was this one said and this one down here said or. Right, the next little thing. A two-way table. So, what a two-way table does is it shows us a list of all possible outcomes. So when you flip 2 coins, there's 4 possible outcomes when you flip 2 coins. So coin 1, you have a choice of head or tail, isn't it? Coin 2, you have a choice of head or tail. So on coin 1 and coin 2, if you get a head and a head, you get head, head. If you get a head in coin 2 and a tail in coin 1, you can get head, tail. If you get a tail in coin 2 and head in coin 1, you can get tail. Or else you can get tail and tail, which gives you tail, tail. So there's 4 possible outcomes. HH, HT, TH, TT. So that's what sample space allows us to do. And we're going to do a few of those in a minute. Right, the next thing. Another sample space, except this time it's for dice. And what you do here is, below shows the result of rolling 2 dice and adding the scores together. So this comes up nearly every year. This is very important, right? This comes up nearly every year. Rolling 2 dice and adding the scores together. Here, if I ask you what is the probability of rolling a 2? Here we are. Is it here or here? Here, wasn't it? Close. It's 1, because the only way you can get 2 if you roll 2 dice down together is to get 1 and 1. Over how many options altogether? 36. 6 times 6. So the only way you can get a probability to get 2 when you roll 2 dice is 1 in 36. The only way you can get it is 1 in 1. Julianne, if I ask you what's the probability of getting 3? 2 over 36. You have 2 3s there. You can get a 1 and a 2, or a 2 and a 1. You roll 2 dice. What is the probability of getting 10 or higher here? Exactly. 1, 2, 3, 4, 5, 6 over 36, which is 1/6. So that's how sample space will work there. Very finished actually, how much you can probably do. Small chapter. Right, off you go and fill in this table and answer these questions. So read the question, fill in the table, and answer the questions. Just jump to the title really quick.
And then now that finally nothing. I left and then you left. That's how I did it.
spinning 2 spinner, and what are we doing? Our 2 scores were multiplying. We're multiplying the 2 scores. Right. Let's have a little look at it. So our table should look like this. 1 and 1 is 1, 1 and 2 is 2, 1 times 3 is 3, 1 times 4 is 4. 2 times 1 is 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. We all happy with that? Even. Score of 4. 2 over 12, 1 over 6. Right? Broke it down. An even number. Jeremy. 1, 2, 3, 4, 5, 6, 7, 8. Julianne, the last one, a score of 8 or more? Brilliant. Right, off you go and wrote this one. Oops. Right, guys. The candidate shows that random what is the probability he she obtained a grade A? 4 over 30, break it down. 2 over 15. A C or a D, Jeremy? Good stuff. And a grade C or higher, Julianne? 20 over 30 or 2 thirds. Good stuff. Right. Next one is tree diagrams. So, tree diagrams are generally used and are sometimes used instead of two-way tables. Alright, so two-way tables, tree diagrams are the same thing. What they do is they show you all the possible outcomes. Is that okay? So for example, on spin array, the probability you get an array is 1 over 4. The probability you get in blue is, and this one over here, the probability you get in red is 3 over 5, and the probability you get in blue is 2 over 5. So for example, if we were to label it out, we get red or blue, when you spin the first time, you can get red or blue and red or blue. Does that make sense? So if you were to get red, it would be 1 over 4. So red and red are multiplying or adding when we say and? Multiply. So 1 over 4 and another red, which is 3 over 5, you get 3 over 10. Or you could get red, blue, which would be 1 over 4 by 2 over 5, which is 2 over 20. Or you could get blue the first time and then get red, which would be 3 over 4 by 3 over 5, which is 9 over 20. Or get blue, which is 6 over 20. Which is the most likely to get of all 4? To get blue and then, which makes sense because there's more blue in this and there's more red in that. But that's what a tree diagram does. It shows you all the possible outcomes. So, for example, Harry Kane. So, I teach all boys, so something soccer related. So, 2015, 20 goals after 50 games. A tree diagram of the probability of Harry Kane scoring 3 games in a row. So, you couldn't do a two-way table if it was 3 games in a row. It looked something like this. So, they get bigger. And even the circle, if you were 5 and 6 of these. Much bigger. So he either scores or misses, and then you can, off this one you gotta go either scores or misses. Off this one you gotta go either scores or misses. Off every branch then for third game he either scores or misses, scores or misses, scores or misses, scores or misses. So if you think about it, if he was to score 3 games in a row, score, score, score. If he was to score in the first 2 and miss in the third, score, score, and then miss. That's how you read. Is that okay? So that's the whole probability. So if I said to you here, what is the probability that Harry Kane scores 3 games in a row? What's the probability Harry Kane scores 3 games in a row? It's 2 over 5 and multiply. 2 over 5 multiply by 2 over 5 multiply by 2 over 5. You can use the calculator if you want, don't worry. That's a big one. Work out the rest of you what? Eight over 125? 8 over 125, exactly. Scores. 2 over 5 by 2 over 5 is 8 over 125. So the probability of him scoring 3 games in a row is 8 over 125. Right. The next one. Calculate the probability Harry Kane doesn't score the first 2 games, then scores. So how would I do that? Doesn't score in the first 2 games, then scores. What would I say? Brilliant. He misses, and then he scores. Can you see how we read it here? This is how it helps. Like, for example, I go into he scores, he misses, he scores. He scores, he misses, he scores. That's how we read it here. That's why it's so handy. All the options are laid out in front of us. So, for example, for that one, we have 8 over 125. Is that okay? Right. The one I want you to get me is get the probability he misses, scores, misses. So, once you get the probability he misses, he scores, and he misses. What do we get? Good stuff. Right. The last thing then, expected value. So, expected value is the outcome multiplied by the probability. So, take down the table here. Expected value is the outcome multiplied by the probability. Right. So, this is actually what they use in like betting companies and casinos to figure out to make money off the water. Is that alright? So, for example, the cost of a spin in a casino is €6. Is this considered good value based on the expected value? So you walk into the casino, you're over in Vegas for the weekend, €6 in the pot. You going to spend it on this game or not? You going to gamble it all? You like some chance? Right. There's actually maths behind whether they figure out how we figure out how to do this. There's actual maths, alright? So, for example, we have to make out a table. So our outcomes are €10, €5, and €4. Is that okay? €10, €5, and €4. We then get the probability, and then we're going to get something called over here called the expected value in the third column. So the probability in the first column, and it's going to be expected value in the last one. Jim, what is the probability of getting 10 here, do you reckon? 1 over? I wouldn't say 1 over. 1 over 2. It makes up half the circle. You have half the probability. It makes up half the circle. So it's half. Julianne, what do you reckon is probability to get €5? 1 over 4. And what do you reckon Emer is probability to get €4? 1 over 4. So 10 is bigger because obviously it takes up half. You can see it takes up half. Right. What you do then is expected value is the outcome, i.e. 10, 5, 4, multiplied by the probability that corresponds. So for a tenner it's a half, for €5 it's a quarter, and for €4 it's a quarter. So what's €10 multiplied by a half? €5. What's €5 multiplied by a quarter? €1.25. And what's €4 multiplied by a quarter? €1. So the expected value of this game then is €5 plus €1.25 plus €1, which is €7.25. That means, even though it's not a value there, every time you play this game, you should expect to win €7.25. I know you're going, that doesn't make sense. So you can only win €5 or €4 or €10. But in the long run, you kept playing this game over and over and over and over. For every €6 you spend, you expect to get back on average. So every time you play this game, you should win back €1.25. And that's how casinos work. So casinos wouldn't charge you €6 to play this game. They charge you €7.50 or €8. So in the long run, the more and more, you might win the first, you might take money off them 2 or 3 things. But in the long run, they're going to win more. And that's how they work all of them. We do not promote gambling to under 18s. Certainly not. Right, let's do a few exam paper questions so based on what we've just done for the last half an hour. Alright, so first things first. So that was in 19, paper 2, question 8. Off you go and have a go at this. area and volume in this to do with nets then as well. Right, guys. The net below is folded to make a fair die. What number will be opposite the number 7 on the die? Anyone know what's going to be opposite number 7? 1. So, if 7 is there, 3 is going to be folded up to the side, 5 is going to be folded up, and 8 is going to be folded up, so 7 is at the bottom. Is that right? So if I was to draw a horrendous cube, my God, that's terrible. So 7 is underneath here. Is that alright? 3 is folded up to the side, so 3 is going to be on this front face. 8 is folded up to the side, so 8 is going to be there. And then 4 is folded up the side, so 4 is going to be over here. So you're going to be left with 1 on top. Is that okay? 1. Right. The die is rolled once. Find the probability that the number rolled is greater than 6. How many numbers are there greater than 6? 2 over 6, which is 1/3. The die is rolled 60 times. How many times would you expect an odd number to be rolled? So how many odd numbers is there? 4 odd numbers. 4 over 6 multiplied by, which is 40 times. And there's your expected value or expected probability. It's the probability multiplied by the outcome. Is that okay? Next one. Have a go at part D. Right. We'll start with this one down here. A subset of a sample space, a collection of one or more outcomes. So it's not going to be sample space then if it's a subset of sample space. So it's going to be outcome or event. Event, exactly. Event. So then the set of all possible outcomes of an experiment. Sample space. And the last one possible result of an experiment. An outcome. Right, 2019, paper 2, question 9. Have a go at it. 2019, paper 2, question 9. Ooh. Can we read that? This is very like a Harry Kane thing. Scroll up just so you can see what's at the bottom. Ooh, didn't want that. Right. I'll give you another minute from here just to finish it off. Right, let's have a little look at it. So, head, tail, head. What goes in here? What goes here? Head. Down here, we have head, tail, head. In here. And here. So this one over here is going to be head, heads, tails. This one down here. Tail, head, head. This one down here. This one here. And this one down here. Tail, tail, tail. Good stuff. How many heads here? 1, 2, 1, 0. Good stuff. Handy marks. With that in mind, have a go and answer these questions. Do these. This will be a bit fun. So we make our money down here. Right, guys, what do we reckon? So, each outcome is equally likely. Fill in the table below the short probability that Jar gets each of the given number of heads. How many times do you get 0? How many times do you get 1, 2, and 3? 1. Right. Fidelma flips a coin 8 times. she can get heads or tails. Write down the number of outcomes that have no heads. 1. The only way she can get no heads is she gets tails, 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 tails. Is that okay? That's the only way. Right. This one, slightly a bit more difficult. Work out the number of outcomes that have exactly one head. Right, up here. How many times did one head pop up? 3 times, isn't it? 1, 2, 3. Right, when she flipped the coin once, how many times did one head come out? How many times would the probability of one head coming out? Just one would be 1. So you can either get heads or tails. When she flips it the first time, it can either be heads or tails. Right, just say she flipped it twice. For example, what would you get here? You get heads, heads, wouldn't you? What would you get here? What would you get here? Tails, head. And what would you get down here? How many times on the second flip do you get only one head? You get it? 2 times. And how many times did you get only one head on the third flip? 3 times. We see a pattern? When you flip it once, you get heads once only. When you flip it twice, you can get heads once, twice. When you flip it, so what's the answer going to be down here? The answer is 8. That's difficult. That one is tough. There's no way to teach that. That's just you had to either spot or down it. All right, that was a tough one. Work out the total number of outcomes for them. It flips the coin 8 times. How are we going to do that? Another tough one. Remember I told you earlier on how do we figure out the number of outcomes? What was the very first thing we looked at? Do you remember the sandwich and the burgers? So when she flips the coin the first time, how many outcomes have you? 2. Right. She flips the same coin again the second time, how many outcomes has she? 2. She flips the coin the third time, how many outcomes on the coin? And then 2, and then 2, and then 2, and then 2. 1, 2, 3, 4, 5, 6, 7, 8. Fundamental principle accounting. And what's the answer? 256 outcomes. Exactly. That's the very first thing we did, the fundamental principle accounting. 2 by 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 2, 8 times. Right. So that was 19. Paper 2, question 2. DEB. Off you go. Have a go at the first 3 bits there. Nearly there, guys. Only 10 minutes. So Nicola rolls a fair die 3 times, records the outcome of each roll. She records an E for an even number and O for an odd number. These sample sets below showing all the possible outcomes. Right, we answered the first few bits. So, Nicola rolls a fair die 3 times and records the outcome of each roll. She records E for an even number and O for an odd number. Complete the sample space below showing all the possible outcomes. 2 have already been filled in. EEO means that Nicola recorded 2 even numbers followed by an odd number. So, if it's even, probably the easy thing to do there is put odd, isn't it? Then she gets 1 even number. Odd. Then she might get odd, even, and then she might get odd, even, odd. Down here, even, odd, even, odd, and the last one, even, odd, even. If you can try keep them, the opposite of the one above it. It's just when you're doing these, the biggest mistake people make is they get confused and put down the same one twice or they leave one out. Does that make sense? So try kind of keep the one above it the polar opposite of the one below it. Right, write down the probability that Nicola recorded 2 odd numbers and 1 even. So where does she record 2 odd and 1 even? There's 1 and there's another, isn't it? 2 odd and 1 even, 2 odd and 1 even. 2 odd and 1 even there. Any more? Which is 3 over 8. Good stuff. Right. Shane says to Nicola, you have the same probability of getting 2 odd numbers and 1 even number as you do of getting 3 odd numbers. So we go back up and we check 3 odd numbers. There's only 1, isn't there? So we answer the question. Do you agree with Shane? Do we agree with what Shane says? No. As the probability is in contrast 1 over 8 to 3 over 8. Off you go. Part D. Can we read D? What do you reckon, guys? At least 1 even. Emer, what you get? You got? Let's look. 1 even. At least 1. So at least 1 means 1 or more. So every place we have 1 or more even. And the only place really we don't have 1 is there. Because there's an even there. There's an even there. There's an even there. Even there. Even there. Even there. And even there. So it's 7 over. Good stuff. Right. Off we go. Last question we want to do today. 5 minutes. 2019, paper 2, question 8. A local gym would like to run 5 different exercise classes at 3 different levels twice a day, as shown in the table below. Do. Gym has 2 rooms available for classes. You can run classes from 7 a.m. until 12 noon and from 5 p.m. until 9 p.m. Each class is 1 hour long. What percentage of classes can be accommodated? They'll work it out now in a second. We all finished the first two ones? Right, let's have a look at it. So Dermot, what you get for the first one then? 45. You multiplied 1, 2, 3, 4, 5 by 3 by 2. Good man. 5 by 3 by 2. Do you remember the first thing we did today? Fundamentals of Principal Accounting. 5 by 3 by 2, which is 5 by 3 is 15. 30. There's 2 there in the last. Oh, I have it on freeze. So, 5 by 3 by 2, which is 30. That's alright, just misread it. Simple mistake. The gym has 2 rooms available for classes. It can run classes from 7 a.m. until 12 noon. So there's 5 hours there, isn't it? And from 5 p.m. until 9 p.m., which is plus 4 hours. So 5 hours plus 4 hours is 9 hours altogether. But there's how many rooms? So how many hours of classes can they accommodate altogether? 18 hours of classes. So they can accommodate 18 hours of classes. And how many classes is there altogether? 30. So how are we going to get the percentage then, guys? 18 over 30 multiplied by 100, which is? $18 divided by 30 multiplied by 100, 60%. That okay? Last question of the day, finish that. That one. The cafe in the gym sells a selection of drinks. Pie chart below shows the sales of drinks. Just on 7 or 2 minutes late now to get this question in. Pie chart below shows the sales of drink on one particular day. Using a tracker, measure the size of each sector in the pie chart and complete the following table showing the size of each sector and the number of units of each drink. So we don't have a tracker, so we'll leave it there. Alright, just realize that there, we don't have a tracker. Right guys, enjoy your Christmas.